Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In this portion of the operating system, we will be focusing on some of the important aspects such as job, process, program, scheduler and its types, interprocess communication, significance of multi-threading, and eventually we will conclude the portion with some of the important and well-known scheduling algorithms that are used in operating system. Now, to begin with, let us try and understand what is a job. Now, as we all know, job is a set of instruction with associated set of data elements. Again, I'll repeat it. Job is a set of instruction with associated set of data elements. Now, here you may have a conflict of opinion that a process is also defined as a set of instruction with associated set of data elements. Now, you may be wondering that what may be the difference between a job and a process. Now, job is an element that is not currently being executed. This implies job is an inactive element. So, job is something that is inactive and resides in the memory. So whenever a job is to be executed, it has to be brought into the main memory and then it has to be provided to the central processing unit and the necessary operation is to be performed. So whenever a job is put for execution, then a job is no further called as a job but it's referred to as a process. So, the major distinction between a job and a process is a job is an inactive element, whereas a process is an active element, active in context to being processed by the central processing unit. So, here, job, which is also known as a program, is an inactive unit, such as a file on a disk. It consists of two important parts. First one is a set of instructions and associated set of data elements. Now, depending on the nature and operation that is performed by a job, it may require different CPU cycles. Again, I'll repeat it. Depending upon the nature and operation performed by or referred to by a job, it may require different CPU cycles. So, although CPU cycles vary from program to program, there are some general types of jobs. So, let us try to understand what are the types of jobs that may be processed by the central processing unit. So, the first one is called as an IO bound job. So IO bound jobs are jobs with many brief CPU cycles and long IO cycles. So say for an example, you perform continuous printing of documents. So here I've given the example as well. So if you continuously print documents, so such kind of jobs would require a very short and a brief CPU cycle, but it would require a long IO cycle. So it's called as an IO bound job. So IO bound job is a job that has short CPU cycles but long IO cycles. Now likewise you have CPU bound jobs. So CPU bound jobs are jobs with long CPU cycles and brief IO cycles. Say for an example, finding factorial of n, or generating Fibonacci series of n, or finding or computing an Euler series. So that is that is a typical example, or it is a typical example of CPU bound jobs. So CPU bound jobs are jobs with long CPU cycles and brief IO cycles. So this is a brief description of what a job is. what is it, what is the major difference between a job and a process, and what may be the different types of jobs that may be there one can perform using a computer system. Now moving ahead, now let us try to understand what a process is. Now, as I've already explained, a process is an active element that is currently under execution. So, a process is an abstraction that refers to running program code on the processor. So, a running job on the processor is referred to as a process. Now, a process is an instance of a program in execution. So, this is well understood. A process is an instance of program in execution. Say, for an example, if you have a program in the memory that is capable of finding factorial of a number. Now, in different executions of this particular program, we can perform or we can determine factorial of n possible numbers. Say, for example, what I imply by that is by or with the help of a program that is capable of finding factorial of n, you can find factorial of 5, you can find factorial of 100, or you can find factorial of any number. So, a process, that is a program under execution, is an instance of a program. So it's an instance of program that implies multiple instances of the same program can exist and are referred to as different processes. So one can find factorial of 6, one can find factorial of 7, one can find factorial of 10. Likewise, a process can find factorial of 20. But you see, it is referring to the same program that resides in the memory. So a process is nothing but an instance of program in execution. That is, multiple instances of the same program are referred to as different processes. Now, a process is definitely the basic unit of execution in an operating system. So, when an operating system desires to perform a set purpose-specific operations or set of well-defined purpose-specific operations, so what it normally does is it normally represents its operation with the help of a collection of processes. So a process is a basic operational unit of operating system or execution unit of operating system. So we have already specified that a process is an active element as opposed to a program or a job which is a passive element. So process is an active element, whereas a program is a passive element, because a process is something that is under execution, whereas a program or a job is a passive element which resides in the memory waiting for it to be executed. Now, there are several attributes. In the subsequent slides we'll learn about the attributes of a process, but for now just remember, attributes held by process includes hardware states, memory, and CPU utilization. So process attributes basically refers to these three categories of attributes. So something that is capable of representing hardware state, state of the memory, and state of the central processing unit. Now, the next important aspect is that process execution must progress in sequential manner. So this is very much true, but in different contexts and in different types of systems, processes are executed based on the nature or the architecture of the system. So we'll come to that as well. But for now, we need to remember that process execution must be done or progress in a sequential manner. Now, let us again revise what we have learned in this particular slide. So we have learned that process refers to a running program code, and it is an instance of a program in execution, which implies there can be multiple instances of the same program, which is referred to as different processes. Now, we have also learned that a process is the basic unit of execution in an operating system, because operating system represents its services as collection of processes. So as understood, a process is an active element, in contrary to a program, which is a passive element. Now, attributes held by processes stores state information about hardware, memory, and CPU utilization, and processes are normally expected to execute sequentially, or process execution must progress in a sequential manner. Now, let us try to understand what are the minimum resources that are required to run a process. So, at a minimum, process execution requires the following resources. First one is a process to run, it requires CPU time, because central processing unit is the portion of the computer system that executes the process. So, in order to execute a process, the CPU has to allot some time to the process, or the central processing unit has to allot some time to the process. So once the CPU is allotted, the process will be capable of performing the associated task in order to attain the said objectives. Second important component that is required for a process to run is memory space. So a process requires memory to store instructions. It requires memory to store data. It requires memory to store global variables, and so we'll come to the different types of memory that is allocated to a program. But definitely process requires memory in order to store the various elements. So second important component that is required by a process is called as memory. Third important resource that is required by a process is called as files. So in order to perform operations, a process would definitely require descriptions that are stored in a file. So until unless these descriptions are not provided to the process may not be able to performing operation. For an example, in case of a C program, so if you want to perform operation of printing, so you use a function printf. Now printf is a function that is defined in the header file stdio.h, or standard input output header file. So in order to make use of printf function that is defined in some other file, that is stdio.h file, a C program has to have in it a local copy of standard input output header file. So that's the reason why we include the header file stdio.h into our C program whenever we want to make use of functions that are described in it. So a process definitely requires a set of files that it may make use of while performing operations. Now, next set of elements that is required by the process for execution is called as signals. Now, signals are very essential components of communication in multi-process system. So whenever there are multiple processes executing in a system or using an operating system, you require proper coordination between the multiple processors. So how it is ensured? By communicating signals. So signals are basic elements of communications that are used for coordinating execution of multiple processes using an operating system. So this is very much important. So in order to ensure that there is a proper coordination between various processes, we require signals. Then after that, we have data structures to maintain process state information. Now this is also very much important. So at different point in time, the process may enter into different states, or during a lifetime of a process may attain different states. So it is very much important for all of us to retain the state information of a process. Now, this is done with the help of a data structure that is associated with the process or with every process. Okay, so with every process, a data structure is associated that stores the state information of the process. Now, this data structure is referred to as process control block or PCB. So we'll come to the description of PCB in the subsequent slides, but just remember that with every process, a PCB is to be associated in order to keep track or record the state information of the process. So here we have learned that for a process to execute or for execution of a process, we require several resources, some of which are CPU time, memory, list of files, signals for coordination, and eventually data structure for keeping track of the status information. Now, let us try to understand what are the different types of memory allocation done to a process. Now, every executing process in a computer system using an operating system requires certain memory. So memory is required in order to store instructions. Memory is required to store data. Memory is required in order to store global data, and memory is required in order to store elements that are allocated memory at runtime. So just see, there are different types of memory allocated to a program to store different types of values or different types of elements. So different types of memory allocation is done to a program for storing different elements of the program, so or a process. So process memory is basically divided into 4 sections for effective working. Again, I'll repeat it. Process memory is divided into 4 sections for effective working. So the first one is called as the instruction section. The second one is called as the global variable section. The third one is called as the stack, and the fourth one is called as the heap. So these are the 4 sections of memory that is allocated to a process. Again, I'll repeat it. First one is called as the instruction section. Second one is called as the global variable section. Third one is called as the stack. And the fourth one is called as the heap. Now, each of these type of memory has their specific purpose. Now, the instruction section of the memory is capable of holding the program instructions pertaining to a process. Again, I'll repeat it. It is a portion of memory that stores the program instruction pertaining to a process. So the instruction section is made up of the compiled program code, as I've already said. Here, the program is read from the non-volatile storage memory and brought into the main memory. So here, the instructions section basically holds the program instructions pertaining to a particular process, and this is loaded from the secondary memory into the primary memory. Now, these 4 type of memory that we will be discussing is it refers to a memory that is allocated to a process in the main memory section. So whenever a program is to be executed, the program has to be brought from the secondary memory onto the main memory. So here, the instruction section of the memory is a section of memory in the main memory of the computer system that will hold the program code. So here, all these types of memory that we are discussing are basically portions of memory in the main memory section of the computer system. So the instruction section is made up of compiled program code read from non-volatile memory when the program is being launched or whenever the program is to be executed. Now the second one is called as the global variable section. Now global variable sections is a section of memory where all the global variables that are allocated or that are being used by the program are being placed. So all the global variables are placed in the global variable section so that these variables can be used by other programs as well. So the global variable section is made up of global and static variables allocated and initialized prior to the execution of the program. So this is very much important. So it is made up of global and static variables and allocated and initialized prior to the execution of the main. So global variable sections will contain all the global variables as well as the static variables. Now the next one is called as the heap. Now heap is the portion of memory which is used in order to store variables that are allocated memory at runtime. So all the variables for which dynamic memory allocation is done is stored in the heap, right? So all the variables for which memory allocation is done at runtime or we go for dynamic memory allocation, so these variables are stored in the heap. For an example, memory allocation done through process like malloc, calloc, realloc, right? So these variables are allocated memory in the heap. Now eventually the stack section. Now the stack section is a section that stores all the local variables. So here the major distinction between global variable section, the heap and the stack is global variable stores all the globally declared variables. Then heap stores all the variables that are allocated memory at runtime, and stack stores all the local variables. So just see the disposition of the variable or description of the variable, whether it's a global variable or dynamically allocated variable or a local variable. We store the variable in different memory cell. So for now, just remember that a typical process is allocated memory, and this memory is divided into four sections, which are the instruction section, the global variable section, the heap section, and the stack section. The instruction section will contain all the binary code of the program that is to be executed. The global variable section will contain all the globally declared variables and the static variables. Then the heap will contain all the variables that are allocated memory at runtime using functions like malloc, calloc, and realloc. Likewise, the stack will contain all the locally declared variables. So just see, the variables can be placed in different locations based on the very nature and the description of these variables. So whether it's a global variable or a dynamically allocated variable or a local variable. Now let us move on to a description of what are the possible states that are there that can be associated with the process. So what are the different process states? So this we have already discussed in the previous section of the subject. Now here we'll just brush through the various states that are there in a process goes through during its lifetime. So let us try to identify all the possible states that a process goes through during its lifetime. So the first is called as the start. So it is the initial it is the initial state when a process is created. Okay, so start is a state when the process is created. Now next one is ready. So the process waits for assignment of the processor so that they can run. So process may come into ready state from start state or running state. So description of so this we have already learned. So description of this is already provided in the previously released video. So ready basically refers to a state of the process where the process waits for the assignment of the central processing unit, and during a process lifetime a process may enter into ready state several number of times. Then the next state that you have is called as a running state. So running state, the process is assigned to the processor by the operating system for executing a set of instructions. So here, running state, the process is assigned to the processor by the operating system scheduler for executing the set of instructions that are associated with it. Now, next one is called as a waiting state. So the waiting state is a state where the process moves into waiting state, waiting for certain resources to be allocated to it. So this is called as a waiting state. So the process moves to waiting state when it needs to wait for a set of resources that it requires for execution. Now, next state is called as terminated or exit. So once the process finishes its execution, the process terminates and it's removed from the main memory. So these are in brief the various states that a process goes through during its lifetime. So we have start state, we have ready state, we have running state, we have waiting state, we have terminating or exit state. So start state is the initial state where the process is created. Ready state is a state where the process waits for assignment of CPU. Now process may come to ready state many times during its lifetime. So it may come to ready state from start state or running state. Then we have running state. This is state where processor is the process is assigned with the processor and it performs the desired operation through the set of instructions. Then a process may enter into waiting state. So in situation, if a process is waiting for a resource to be allocated to it, then process enters into waiting state, and then eventually you have terminated or exit state where the process finishes its execution and it's removed from the main memory. And whenever it's removed from the main memory, all the state information of the process is lost. So I am repeating the same flow diagram of the states of the process that we have discussed in the previously released episode. So here I'll simply brush through the various states and the description. So we have a new process that is being created. So when the process is being created, the process will be queued up in the ready queue. So in a computer system there may be several processes that may be waiting for execution. So as and when the processes are created, the processes are queued up and placed in the ready queue. Now from the ready queue, processes are sequentially selected and then the process enters into running state. So what we are doing here is we are scheduling the selected process and making it and assigning it the central processing unit and making it to exhibit desired operation. So once the process runs, the process eventually terminates. So here the process execution completes, and then the content of the data structure associated with the process, that is PCB, that is lost, and the process is considered to be zombie. So this is the normal course of execution where process is created, process is prepared and then executed, and eventually process terminates. Now process, as we have said, it may move from running state to ready state multiple number of times during its lifetime. So it may happen due to preemption or due to influence of the scheduling algorithm. This is what we have learned in the previous episode as well. So now from the running state, the process may enter into waiting state. So wait state is a state that is entered to by a process when it waits for a resource. Now you can have so wait block basically refers to a situation where the process waits for certain resources to be allocated, and during this period the central processing unit or the CPU or the processor can be assigned to some other process. So there can be two types of wait. One is called as suspend wait, and second one is called as suspend ready. So this we have already discussed in the previous episode, that you can wait the process can wait in the secondary memory either from the course of execution or either from the ready queue. So suspend ready basically means putting the process from the ready queue into the secondary memory that's waiting for execution. Because of unavailability of the resource. Likewise, suspend wait basically refers to situation where the process is moved from the main memory to the secondary memory during its course of execution whenever it's waiting for a resource to be allotted to it. So this is done in order to basically enhance the usability of the processor. So during the time when the process is waiting for the resource, the processor can be assigned to some other process, and the utilization of the processor can be enhanced. So just see, these are the various states that a process goes through during its lifetime. So in this particular episode of discussion, we have learned about what a job is. We have learned about what is a process. We have learned about what are the resources that are required for running a process. We have learned about what are different types of memory allocated to a process. Then we have learned about process flow with the help of a very neat flow diagram that represents the various states of the process, which are ready, new, ready, running, termination, wait block, suspend wait, and suspend ready. So in the upcoming class, we will discuss about process management in a greater detail. Thank you very much. Have a very nice day.